Alright, so this is going to be Unit 3, Notes for Applied Math. We're going to talk about decimal fractions today. Basically, we're talking about decimals, and what I would recommend you use is a calculator. So, using a calculator, I've got this fancy graphing calculator here that has, you don't need one of these, just a TI-30 is fine. But really, all I'm going to do for Unit 3, I'm assuming you can use a calculator for this. You're going to show your work. The way I show work on the problems is the way you want to model showing your work, and we're just going to look at some of the word problems at the end of this. You've got several homework problems that are word problems. By going over the word problems, we'll go over the basic problems too. So the word problems usually are the ones that cause people the most difficulty. So that's why we'll use those. In the back of Section 3 or Unit 3, they have computing with a calculator, and they've got decimals, and they basically tell you exactly what buttons to push for a lot of these problems. The parts of this that will be helpful to you are the squaring and the cubing and that kind of thing. So it does go through some of the keystrokes, like showing you how to do roots and powers. So if you just take a look like here at number 10, it's a problem that has the fifth root of 14.773. And so if you look over on this page to number 10, it will show you exactly how to do that fifth root on certain calculators. So it says that in order to do the fifth root, you hit the parentheses and then 5, and then this button gets you to the root 14.773. It tells you exactly what to do. So these are the keystrokes, or what to push in your calculator. The spreadsheet thing is probably not going to be that helpful for you, unless you're really good with spreadsheets, and you can use that. So what we're going to do is we're going to go back, and we are going to be on page 135. And we are just going to be looking at problems on here and solving these. You are doing the odd problems starting with 139, and we're going to walk through some of the even problems. So number 140, in a parallel circuit, the total circuit current equals the sum of the individual currents. As I read a word problem, I try to pick out keywords that are going to tell me what to do in the problem, and then I try to write down numbers off to the side too if they give me any. The total current of the parallel circuit shown in figure 3.45 down here is 17.5 amps. So the total total current is 17.5 amps when all the lamps and appliances are operating. Find the current, the amps, of the refrigerator in the parallel circuit shown. Okay, so we know that all of these add up to 17.5. The way I know that is it says total and sum. Sum means add, total, add up all of these. So I know that this lamp has 75 watts or 0.53 amps. The refrigerator is the one I don't know. So I need to take this, the lamp plus the refrigerator, plus the electric iron, plus the toaster, and that plus this lamp down here. So I need to add the two lamps, the toaster, the electric iron, the refrigerator, and they all are going to add up to 17.5 amps. Okay, now the question here is, what numbers do I use? Because it's got 100 watts and 0.83 amps. So I have to make sure that I use the right number. My total is amps, so I have to use these numbers that are amps. So the problem I'm going to set up, and the best way to set this up would be a vertical problem. So I would set this up going up and down. So I would set this up, get a little piece of paper up here. So I would write 0.53 plus 4.12. See, I can't add the refrigerator yet, so I'm going to add up all these other ones. Okay, I'm going to add up all these other ones first. So if I add up all these other ones, so 4.12, 8.75, and 0.83. This is what the other four add up to right now. So I could use my calculator. I'll just do this by hand. 3 plus 2 plus 5 is 10, plus 3 is 13. Carry the 1, 8, and those two make 10, 22, carry the 2. So that's 14, and then the decimal just comes straight down. Notice when I added these, I lined up the decimals. The decimals were lined up. All right, so 14.23 amps are what the first, the lamp, the electric iron, the toaster, and the other lamp add up to. So Now, I would have to try to add the refrigerator to that to make it equal 17.5, but I'm looking for the refrigerator. So I kind of have an equation now. 14.23 plus what is 17.50. So what do I do to figure that out? I'm going to take 17.5 and subtract 14.23. 5, 4, let's see, that's 7, 2. I'm just doing my subtraction. You can use a calculator. So 3.27 amps is the amount of amps for the refrigerator. Alright, so let's take a look. Let's just move straight on down to number 142. The part shown in figure 3.46, which is dimensioned in centimeters, okay, is to be made by a machinist. 20 equally spaced holes are drilled along the length of the part. Find in centimeters the total length of the material needed. Okay, so here's what I know. I know that I need to find out how long this is. That's what I'm trying to figure out, how long that whole thing is. They've got a question mark right there for us even too. So we've got 20 equally spaced holes. So 20 equally spaced holes. So that means there's 19 spaces. And that comes from the last notes. There's always one less space than there are holes. One less space than there are holes, one more hole than there are spaces. So there are 19 spaces, and each space, it looks like they're telling me the distance between these two is 1.720 centimeters. So I need to figure out the distance from here to here. I can take 19 times 1.720. Okay, now I can just do that on my calculator. 19 times 1.720, that gives me 32.68 centimeters, and that's the distance from here to here. Now I want to find the distance from here to here, so then I've got an additional 3.18 times 2, so 2 times 3.18, I'll do this on my calculator. 2 times 3.18 gives me 6.36 centimeters, and those two I just need to add together. So plus 32.68 on my calculator gives me the total length is 39.04 centimeters. And the labels are important. Alright, so let's just take a jump to number 144, and we might not look at all these parts, maybe just part A or B. We'll see. So we've got find the lengths of the sides of squares and cubes, or the lengths and of the sides of squares and cubes are given in the table shown. Find the area, s squared, and the volume, s cubed. So the area of a square A equals s squared, and this is the volume of a cube right there. Okay, so if I know the side length, so if for the area of the square, which basically each side of this cube is a square. So the areas of the front surfaces, if the side is 1.85, then the area of the front surfaces will be 1.85 squared. Okay, and so then you're just going to punch that into your calculator. So 1.85, you may or may not have a squared button. Okay, the squared button is right here. Well, find the squared button. If you have a caret button, that'll get you, and then so you'd hit up arrow, the caret button, and then 2, and then enter. And some of you have a button that looks like y to the x. And so then you'd hit that button and then 2. You'd hit 1.85 and then that button and then 2. So you should get 3.4225. It says round to 1 decimal place. So for part A, the area would round to 3.4, because you look at the number next to the 4, it's 2, so it stays 4. So 3.4, and the label on that would be, since this is in feet, would be feet squared. Again, labels are important. Area is always in unit squared. Okay, so now the volume, to find the volume, you take the side and cube it. So that would be 1.85 cubed. So now I have to use that y to the x button, or that caret button. So 1.85 raised to the third power gives me 6.33. That would round to 6.3 because the number next to it is 5 or less. So this would be 6.3 feet cubed. Volume is always in cubic units, and that's just basically how you do all of them. So this one you take 0.8 and square it, and here you take 0.80 and cube it. And then the label on this would be meters squared, and the label on this would be meters cubed. All right, let's take a look at a couple more. So let's take a look at 146. So number 146, a carton in the shape of a cube, so it would be this same shape, is designed to contain 1.25 cubic meters. Now this label, it says cubic meters. What that means is 1.25 meters cubed. So this tells me that this is the volume. This is the volume. How do I know that? Because only volume is in meters cubed. Okay, it can't be a side if it's got a cubed on the label. What is the maximum height of an object that can be packed in a carton? So we've got a shape this size, its volume is 1.25 meters cubed. We want to know how, if I put something in this box, what is the maximum height? Okay, so in other words, we need to know the side length. So we're looking for the side length is what, and that's going to be, the label on that's going to be just meters. So the object is not tilted and it lies flat on the base of the box. So it says the side is the cube root of the volume. That's our little formula. So the cube root is the same as the 1 divided by 3 power. So you can use your cube root to get a cube root. You would first, in most calculators, you're going to type in your volume, and then you're going to hit your second button and then your y to the x button. It might be x to the y to the x, I don't know which it is. But the second y to the x actually looks like this. It's like the x root of y or the y root of x. So if you have the caret button, you can use that. If you have the caret button, then you can type in your volume, hit the caret, and then in parentheses 1 divided by 3 power. So that's how you're going to do it. So what we need to do for 46, we need to plug our volume in for V. So our side length is going to be the cube root of 1.25. And if you look at what's the cube root of meters cubed is just meters. So in my calculator, I'm going to type in 1.25, and I have the caret, so I'm going to raise it to the 1 divided by 3 power, and that's 1.077. That's going to round to 1.1. So the side length is 1.1, and that would be meters. And that would be your final answer. But see, all this stuff that I'm writing down is the work that you would show. All right, I might have time for one more, or maybe we'll just call it quits for the day. I think that's about all of them we're going to do for this video. I guess we could do number 150. So 150 we'll do. So a steel fabricating firm is contracted to construct the fuel storage tank shown in figure 3.54. The specifications call for a tank height of 22 feet. So H is 22 feet. The tank must hold 25,500 gallons, so G is 25,500, and of fuel. And D, it says D, is equal to the square root of 4 times G divided by 3.1416 times H times 7.479. Find the diameter to the nearest 10th foot. So this is the diameter, that's what we're looking for. We've got this picture, so we've got the height, and we're looking for the diameter. So all we're going to have to do is plug G and H in here and follow the order of operations. So D will equal the square root of 4 times 25,500, all divided by 3.1416 times 22 times 7.479. So all I'm going to do now is follow the order of operations to work this out. I can do this actually all at once in my calculator if I type the square root first of all. So your square root, some of you have a square root button, some of you don't have a square root button. I have to hit second square root, and then in parentheses, anything on the top is going to go in parentheses. Then I'll hit the divide sign, and then everything in the bottom has to go in parentheses too. So begin parentheses, 4 times 25,500 in parentheses, divided by 3